Okay, so now let's quickly go through the 2022 section B, okay? And let's see how far we can go. So we start with number B1. Okay, it says, interestingly, when an alkane molecule reacts with a dihalogen, we know that they want us to put a mechanism. Here we have alkane and dihalogen. We know about that one. Okay, that is the one where we are putting the radicals. Okay, in the influence of heat or ultraviolet radiation. Blah 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 blah. Name these three steps. The reaction is described by a mechanism. Yes, in three primary steps. Name the three steps and show the reaction mechanism under each step, including reaction intermediates that are required to explain the formation, blah, 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 blah. Use methane. Okay, so there we go. Number B1, let's go with it. Okay, we'll say the first one is going to be your initiation. So we'll start with initiation. We're going to give it the name initiation. And we are using methane, but the halogen will just use X. Okay, so we have two halogens like this, and you can put your two electrons like this that are in the bond. Okay, if you want to put lone pairs, it's up to you, like this, to put lone pairs on your halogen. Okay, to put lone pairs on your halogen, you know that it has 6. Then what are you going to do? You are going to show that the first thing that happens is going to be, in this initiation, is going to be the movement of these guys homolytically. So equal sharing like this. Okay, this electron comes to him, this one comes to him, and it's going to be like this. And what it's going to give us is radicals. Okay, well, if we put lone pairs, I think radicals might be a bit hard. No, but it's okay. Here we have our radicals. 3, 4, 1, 2, 5, 6. Okay, and this reacts with, ooh, my gosh. Okay, let's just ignore the lone pairs. Let's put this guy like this. Okay, X and X, and then you show it is going to be the 2 free radicals on them like this. And then this is the initiation step, right? Then we go to chain propagation. So chain propagation. Now we are dealing with methane. Remember, we are doing the chain propagation. Now remember, ooh, I forgot the HV or heat. Okay, I forgot the HV to say ultraviolet or heat. Okay, that's what is needed here at this first stage. And then in chain propagation, our radicals are going to attack the methane. So because they said we are using methane, so it's going to be like this. Your X goes to attack methane, which is going to be, you say plus, we say plus, this guy plus methane, which is going to be like this. Okay, here's your methane like this. All right, and don't forget what then happens is going to be now this guy come here, and then he comes there, and then he comes there. Okay, that's what happens. One of the hydrogen is coming here, but then the other one is going back to carbon. So what we will end up having is going to be, now we're going to have our nice chlorine, the carbon, sorry, which is going to be like this. Okay, these 3 bonds, but this one is gone, and it's now a radical. And then we say plus HX. Okay, that's going to be like, all right, so this is going to be 1 where we have it. And then now the other one, what's going to happen in my chain propagation is that when I form this, don't forget that I'm going to form this radical, but this radical is not going to keep quiet. He's going to come back and fight, because that's his nature. He's going to fight an XX. Okay, so it's an XX plus this radical. We need him to fight. We want that fight. That's the fight we want, because it produces exactly what we want. Now, what are they going to make now? We have it like this. What are they going to make? We know what they're going to make. He's going to steal a halogen. So what we do is we show an arrow coming from your radical like this, going to your sign. Okay, and then you have your halogen one from the bond going half arrow. Remember, it's a half arrow. Remember to put half arrows. Remember to put half arrows, please. It's going into the bond like this, okay? And if it's going, then obviously the other one is coming to him. And at the end of the day, what are we going to have? This chlorine, this carbon is now like this. Hydrogen, 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 and then X. And then we say plus, what are we going to have? The radical again, X radical. Okay? And once we have it like this, wow, we have managed to put one halogen in there, and that's going to be interesting. Now we go to chain termination. Okay. Now what happens in termination is that two radicals meet. Don't ever forget. So we can start with the two radicals to say X plus this one plus the other one like this, and they form XX. And then you're going to have your two weird hydrogens. They were hydrogens like this, hydrogen, 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 like this. If it meets another thing, like this, okay? If these two are to meet, normally we like to write it easier for us when we are now putting the chain termination. We don't put them in displayed format. Only on chain termination, that's when we don't put them in displayed format. We like to just write it as CH3, okay? We like it to write it as CH3. Let's first say CH3 with the radical meets a CH3 with the radical. Okay, and this should therefore become a CH3. Okay, and then the last one is what happens if an X meets a CH3. Okay, then you're just going to have it as a CH3X. This is the chain termination stage. Okay, so that's it, and you'll be done. You'd have gotten your 15 marks. Wow. 15 marks? Yes. Now, here's one thing you might put. Okay? No, I think you could leave it like this. Okay? And this is going to be your final solution, and you're done, and you could have it like this. Bye.